So we're going to look at some problems now that kind of ask you to think backwards a little bit. We're asking you to recognize an expression, which one of the three sum and difference formulas does it fit, and can you use the formula backwards, go from like this side to this side to get an answer. So we're going to look at a couple problems that simply say, write each expression as the sine, cosine, or tangent of one angle. So if I look at this first expression, sine of 40 degrees times cosine of 21 degrees minus cosine of 40 degrees times sine of 21 degrees, I see sine of, I'll call 40 like U, and I'll call 21 degrees V. And I would ask the question, if I do that, which of these sum and difference formulas does that look like? I think it's the sine one, because the sine and cosine are together here. And which one is it for? It's this one here, right? It's this bottom one that has the minus sign on it. So it must be the formula that uses the difference of those angles. So this whole expression here is simply equal to the sine of 40 degrees minus 21 degrees, which is the sine of 19 degrees. And notice they didn't ask me to evaluate that or anything. They just said, write it this way. We're done. There's my answer. I think it's a little more obvious to look at the second one here. Tangent of 77 degrees plus tangent of 32 degrees, all divided by 1 minus tangent of 77 degrees times tangent of 32. And if I look at maybe letting U be the 77 degrees and letting V be 32, it's obviously a tangent one, isn't it? And the formula that has the plus on top and the minus on bottom would be the sum of the angles. So this must be the tangent of the sum of those two angles, 77 degrees and 32 degrees. So this whole expression must be equal to the tangent of, mental math, I think that's right, tangent of 109 degrees. Think these are pretty easy? I hope so. Okay, let's do maybe the toughest version of this type of problem, which simply says find the exact value of this. And I want to point out that you could do this by evaluating at least this first expression, each of these. I know how to find cosine of pi and cosine of pi over 3 in the unit circle, but I think it's easier to use the structure that you noticed, kind of the way we did with the two previous problems. So I'm going to let cosine be U. I'm going to let V be pi over 3, and I would then say, which of these formulas does this look like? You know, the cosine terms are together, and so are the sine terms, and that only happened over here in the cosine formula. And I noticed that the two terms were added together when we use a minus sign. This must all be the cosine of pi minus pi over 3. And if you subtract those angles, pi minus pi over 3 is 2 pi over 3. And I can get cosine of 2 pi over 3 from the unit circle. Cosine of 2 pi over 3 is a negative 1/2. So I think that's my answer. One way you might check that would be to actually evaluate each of these four trig function values and see if you don't end up with a negative 1/2. I think you will. In fact, it might be worth pointing out that sine of pi is 0, so this whole term would go away, but I digress. Now I argue that you don't have that same option here on the one on bottom because I can't find 2 pi over 5 or 8 pi over 5 on the unit circle. But I notice that they have the repeated structure, the same thing we've been looking at in this video. So I'll let U be 2 pi over 5. I'll let V be 8 pi over 5. And I think that this is the sine formula where you add the two angles together. So I think that this whole expression should be equal to the sine of the sum of 2 pi over 5 plus 8 pi over 5. And if you add 2 pi over 5 and 8 pi over 5, you get sine of 10 pi over 5. But 10 pi over 5 is just 2 pi. And I can tell you what sine of 2 pi is by looking at the unit circle. It's 0. So I bet that whole term is equal to 0.